All right, welcome back, students. I see you survived the weather. We're going to go ahead and get started doing some review for the NIMS certification test. That's a pretty big test that we have to take in the machining class. So let me share my screen with you and get right to it. Hang on just a second. Hope you can see the screen okay. All right, we know when you're removing metal, you're essentially machining it. When you 3D print metals or plastics, you're adding material. So metal machining, you're removing metal, and 3D printing, you're adding either plastic or you can 3D print metal as well. Okay. So understand the difference between 3D printing and machining. We have an engine lathe. You were briefly introduced to it. You will have a demonstration lab where you'll get a chance to work with the lathe itself. You will. Okay. So the engine lathe is one of the most important versatile machine tools in the machine shop. You can do quite a bit of things with the lathe. Okay. And predominantly though, if you look, most of the things that you make on the lathe is round stock, parts that are cylindrical, okay, cylindrical in shape, okay. So it's used to remove, again, unwanted material. Some material you want to keep, some material you want to get rid of it. Basically used to form cylindrical and even conical shapes. So the lathe, remember the lathe is going to what? Form cylindrical shapes, such as a table lathe. Now, a wood lathe be used to make a table lathe, unless, of course, it's a metal table. So, but to give you an idea, a table lathe is round and cylindrical, and it would be made on a wood lathe. Okay. A shaft, a shaft would be made on a metal lathe. Okay.
Hey, do you have an extension cord?
Pardon?
Do you have an extension cord?
I'm sorry, I sure don't. Now, the engine lathe is a process that uses a single point cutting tool. Single point cutting tool. Okay. You see the part that actually touches the tool that actually touches the part. It's a single point that makes contact with the workpiece. Okay. And there's different styles of these cutting point tools, and you'll see them a little bit later on. The lathe can be used to machine grooves and cylindrical parts. All right. Also can be used for cutoff. You can actually cut a piece off, almost like a saw. Okay. It's not a saw, but you can cut the end of the piece off. Okay. You want to cut it off, you can cut it off. So therefore, it can be used to make grooves and do cutoffs and machine threads. You know how you make threads with a die manually? Okay, well, you can also make threads with a lathe. Okay. Now, this does not look exactly like the lathe that we have in the shop, but this is an engine lathe that looks very similar. These are some of the various parts you need to be aware of, like the headstock. Headstock usually houses the speed controls and the feed controls. You have a cross slide and a carriage and the ways, which helps you to guide the tool. You can guide the tool transfer in parallel with the ways, and also you can move the tool so that it's perpendicular to the ways. You have a lead screw here that allows you to run the carriage automatically. So you can run it manually and you can also run it automatically. You pull up on a lever and it runs by itself. You have to be very cognizant what's going on around you when you do that so you don't tear up the machine or the tool. We also have the tailstock. A lot of times it's called the tailstock setover. If you look at the tailstock right here, Landon, if you look at the tailstock right here, this is where you would put in a drill. For example, if you wanted to drill into the end of the stock. Okay, we're moving pretty quickly here. So now the chuck. This is a universal chuck. In other words, the jaws all move simultaneously. We also have some independent chucks where you have to adjust each jaw independently. These all move simultaneously here, but if you see four jaws, pretty good chance that that chuck you have to adjust each one of the jaws independently. This all moves at the same time. Mr. Morris prefers this. It's very easy when I'm trying to center the workpiece. So as you can see here, we have a cylindrical workpiece, right? We have a cylindrical workpiece. And again, most of the things you're going to be machining on the lathe will be cylindrical, right? Here is a breakdown of some of the different machine operations and parameters. For example, we have turning, we have drilling, and we have milling. Those are some of the three main things you can do on the lathe. I won't read this chart in detail here for you, but you do need to know that you can turn, you can drill, and you can, well, actually, the milling is on the milling machine. Sorry. You can turn, you can face. That's the two main things you can do on the lathe is you can do some turning and some facing, and then you can do drilling. All right. Now, what is drilling? Look at this picture. It should look very familiar to you. This is a twist drill. This is a drill bit, also called a twist drill. And you see the feed that you can give it a linear speed here. Okay, this would be one perhaps you would use on a milling machine where you're not necessarily doing it manually. The machine is controlling the feed rate. All right. You also have an RPM. So when you hear RPM, that is revolutions per minute. Okay, that's the speed at which the tool rotates. And then you also hear one called feed rate. That's the speed that the tool moves linearly. All right. So what does drilling do? It creates a round hole in a work part. There's your hole, right? Contrast with boring. Now, on a drill, you only cut at the very end of the work of the tool. It doesn't cut on the edges here at all. A lot of people think that it will cut on the edge. It does not. Now, the milling tool will cut on the periphery, but the drill bit does not cut on the periphery. That's why they call it a single point cutting tool, because it only cuts at the point. So what is the purpose of the twist? The purpose of the twist is so that the metal has a channel to come out of the hole. In other words, if you didn't have that twist, where's the metal going to go as you drill in it? It's got to go somewhere. So it comes up. By the way, this is called the flute. It's called the flute. So also, in addition to allowing the chip to come up the flute, it also allows a passageway for the lubricant to get down to the cutting end here, to the cutting point. So it does two things: chip removal. The flute serves to help remove the chips, and also allows the lubricant for the cutting oil to get down to the cutting edge of the drill. Because once you stick it in the hole, just picture this for a minute. If you didn't have that flute, how would the oil or the cutting fluid get down into the bottom of the hole? It has to go down the flute. All right. Here's a couple different milling forms. They're called forms because on the milling machine that we have in the shop is a vertical milling machine. Okay, vertical, and the tool. Notice the axis of the tool, right? The axis of the tool is actually vertical. So that's how you can remember if the tool is being used on a vertical milling machine or horizontal. In this case, notice here's the axis of rotation, and it's what? It's perpendicular. The axis of rotation is perpendicular to the work part or the table. All right. By the way, this is called face milling. You're removing a part of the face of the material. Face milling. Over here, though, I can see the axis is horizontal. This tells me right away that this tool is used on a horizontal milling machine, which we do not have one of those. I can show you some YouTube videos of a horizontal milling machine later, but just keep in mind that it's basically based on the axis of the machine or the spindle. In this case, again, one more time, it's perpendicular to the workpiece and consequently perpendicular to the table. Over here, though, notice that the axis is horizontal and it is not perpendicular to the table, but parallel to the table. All right. Turning, as I said earlier, is for the lathe. When you hear the term turning, they're talking about the lathe. It has a single point cutting tool, removes material from rotating the workpiece. The workpiece rotates and not the tool. The workpiece rotates. Think about the lathe versus a drill press. On the drill press, what rotates? The work or the tool? Can you answer that question? The tool rotates, right? On the lathe, though, the tool does not rotate. The workpiece does. So there's a difference. Here are some types of cuts: facing, contour cut, if you want to give a certain shape. Again, you might cut something that looks like a chess piece. You could cut a chess piece on a lathe, right? Chamfering, parting, and grooving and threading. All right, here's some examples right here. Look, this goes quick. Turning. Look here. Here is your single point cutting tool. It can move parallel to the ways, or it can move perpendicular. It moves linear. Single point cutting tool moves linear. Okay. The workpiece is rotate. This is called turning. There's a difference now between turning and facing, which I'm going to show you. Facing, you are just facing off the end of the workpiece. That's it. You're not turning here, you're facing. You're cleaning up the end of the workpiece. All right. Here is another example of facing. Look, here is your tool is feeding in towards the center of the workpiece. So the tool is fed radially inward. The tool is fed radially inward. Okay, you're going to face off just the end of the workpiece. All right, here's contour cutting. Look, you can cut some unique shapes on the lathe. And one of the examples I gave you was, of course, this is a metal lathe, but you could make a leg for a table. Okay, any type of shaft that has a unique contour shape to it. Okay, excuse me. Instead of feeding the tool parallel to the axis of rotation, the tool follows a contour, not necessarily straight. So this is not straight. The tool is feeding some sort of contour. By the way, you see this example of a tool here? You don't replace this part, you only replace the tip. These are called inserts right here. You replace the inserts. They wear out, you unscrew them, you put a new one in. Sometimes, like this one here, you can just rotate it around and make this point the cutting point and this not. So right now, this is the cutting point. You can just screw it, unscrew it, rotate it, screw it back down, and you can change the cutting point. Okay. Here is turning. So you have the workpiece, you have your single, look, it's not facing, we're not facing, we are now turning. We are removing material around the periphery of the workpiece, okay? So notice you can vary the diameter at which you're cutting the part. Depends on how much you're going to remove. Here's a chamfer. Look, y'all should look at this. You've seen chamfering before because you've done it, right? But you've done it, what? You've put chamfers on things manually by using the belt sander or the disc sander and basically creating your own chamfer. You will do that on this next project. We have two projects we're getting ready to start working on. Actually, three of us already started working on one of them. So this is how, look, a chamfer is a what? A beveled edge on the end of the round workpiece. Why do you think we chamfer stuff? One is to remove the sharp burrs and sharp edges. Another sometimes has to do with the fit. Maybe this shaft is going to fit into a hole and the chamfer helps it to center. It helps to center itself into the hole. Okay? See this bevel edge? It's going to help the shaft center itself as it goes into the hole. If you want to cut something off, look here. You can actually cut the end of the workpiece. You can cut a piece off. The tool is fed radially into the workpiece at some location, whatever your desired location is, and you can actually cut off the part. So you can actually cut off the tip of the part here. Okay. Guess what? You can also make threads. But you don't do this manually, you do this with the automatic feed. Remember I said there's an automatic feed on the drill press. Excuse me, I said drill press, forgive me. I meant the lathe, right? There's an automatic feed. This is a thread cutting tool here. See the shape of the tip? It allows you to cut threads into the workpiece. And it's moving. As it's cutting, that thread profile is actually moving to the left. It's not stationary, it's moving. So the pointed form tool is fed linearly across the surface of a rotating work part parallel to the axis of rotation at large feed rate, thus creating threads. You're creating threads here. Other operations you can do on the lathe is drilling, boring. You can also tap on a lathe, but you have to be you have to really truly know what you're doing to tap on the lathe. You would use the tailstock setover, for example. You would actually put the threading tool into the tailstock setover, and it is a process, believe me. You have to be very careful so you don't snap the tap. Reaming is an operation where you're basically taking an existing hole and you're cleaning it up. It's sometimes we use a boring tool to make a hole, or a drill, and then a boring tool, and then it looks kind of rough inside. The hole does. You can ream the hole out and make it much smoother. Okay. And then we have something called knurling. You have to understand what knurling is. If you look at a metal part and it has like a hand grip, but it's still made out of metal. I mean, it's not a rubber handle. It's some hammers, some metal hammers have a knurled end that you can grip. Okay, so you can actually create an area on the part by knurling that gives you a place to grip the tool so it doesn't slip out of your hand. It's a knurling operation. Here is the look here. I told you about, look here, this is a very important picture. This is the tailstock set over. What does the tailstock have in it? A drill. Let me ask you a question, Bill. Is the drill rotating or the workpiece rotating here? Pardon? Is the workpiece rotating or is the drill rotating?
Uh,
The workpiece is rotating, the drill only moves linear. As opposed to a drill press, the drill rotates. But on a lathe, the drill does not rotate. It gets pushed in linearly. The workpiece is rotating, so that's how it drills the hole. That's a good question that you might see on a test. Is on a lathe, is the drill rotating or is the workpiece rotating? So here's an example how you would drill a hole on the end of your workpiece. Look here, folks. If you're going to bore a hole, you first have to drill a hole. This is your boring bar. Look, see your boring bar? It's got a single point cutting tool here. As you open it up large enough for to get the boring bar in there, you first drill it. You first drill the hole, then you come back with the boring bar. It has a single point cutting tool, and you're going to gradually do what? You're going to gradually take material out. So this thing is rotating, right? And this tool, you're able to move this tool linearly. And as you do, you can take more or less. You can either increase the diameter of the hole or decrease it. Okay. Well, you can't decrease it from the size of the original drill, but you can open it up a little bit or you can open up a lot. Depends on how much material you want to move. Here is an example to the right. See, here's a workpiece and they're boring a hole. Boring is different than drilling. Okay, as you can tell, this is not a drill, but you still can make a hole because there's a single point cutting tool right there that's cutting the material as it rotates, and this tool is moving to the left as it's doing it. Look here, same thing. Look, you can put a tap into the tailstock setup. See, here's a hole on a lathe that's actually being threaded. Okay, you guys are experts at threading things now, so you can see what's going on here. Here is a reaming tool. Maybe you've never seen one before. Some of them have twisted flutes, some of them have straight flutes. But look, it's not taking that much material out of the hole. It's taking a very, very minute amount. It's almost like it's shaving the inside of the hole. The reaming tool is like shaving the inside of the hole. Okay. All right, last slide. Give me your 100% attention. Then we'll watch the video, and then I will allow you some free time to work on stuff. You see this? This is a knurling tool. It's not cutting. Look, it's not cutting this material. Mr. Morris, what is it doing then if it's not cutting the material? You see, it's actually applying a force. It's compressing the material. So it's pushing some material in and some material out. More time, it's pushing some material in and some out. How many of you ever seen like a hand grip on a metal tool? And this is that. They had to use a knurling process to create that texture. Okay. Another thing you can do, what happens if the shaft is too small for the hole? It happens. What happens if you want the shaft to fit the hole tighter? If the shaft is cut too small, the diameter of it, and it's too loose in the hole, what you have to do is if you take a knurling tool, you actually, believe it or not, by pushing in, you're pushing some material out, which can cause more of an interference type of fit, a tighter fit, if you will. So it has been used for that as well. All right, so you will have access to this video. Please make sure you're watching these videos. I won't be able to post it until later, but you should watch it to be prepared for your NIM certification test. Again, it's probably going to happen end of February or sometime in March. Depends on how quickly we learn the material. We've had a lot of snow days. We've had a lot of sickness. We've had a lot of tests at your home schools, which has interfered with us being able to move at a much faster rate. So I'm going to stop this video here and I'm going to post it later. So let me stop it. See everyone later.